the mole is the number of carbon-12 atoms in 12 grams of a carbon-12 sample. So since the original atomic mass scale was based on the carbon-12 atom, and we have this relationship that on the periodic table, the mass of a carbon can be read in terms of atomic mass units. It'd be nice to have the same mass read for a large collection of those atoms. And so as it turns out, 12 atomic mass units of carbon-12 is equal to 1 atom, and exactly 1 mole of carbon-12 atoms weighs 12 grams. All right, so it's a way of getting from a microscopic unit to a macroscopic unit. So we have to look at these atoms, molecules, compounds, and whatnot in terms of moles to get to a macroscopic scale. All right. So when we report masses in terms of grams per mole, we refer to the unit as the molar mass of the atom. Okay. If we're talking about the individual atom, we'd say it's 12 atomic mass units in the case of the carbon-12. But if we're talking about a collection, and that collection being 6.02 times 10 to the 23rd, or a mole of them, then we call that the molar mass, and the unit is grams per mole. All right, so just always remember that the molar mass value reported on the periodic table is actually the weighted average of all the isotopes of a given element, which can now be interpreted as atomic mass units per atom or grams per mole, since we have this very special number called the mole. So we'll be coming back to the mole many times throughout the course of the rest of the year. I just want to take a minute to remind you of the significance of the mole and the value of the mole. Okay. All right, so now we have this ability to interpret chemical equations differently, and we'll be using this a lot more in Chapter 4. But for now, we know that carbon dioxide is the result of a combustion reaction between carbon and oxygen. And the carbon can be in the form of just carbon, like in the case of coal or graphite, or it can be in the form of a hydrocarbon, in which case you're going to get carbon dioxide and water as products. But if all you have is carbon and oxygen, now we can interpret this chemical equation as 1 atom of carbon plus 1 molecule of oxygen gives 1 molecule of carbon dioxide. Or you can say 6.02 times 10 to the 23rd atoms of carbon plus 6.02 times 10 to the 23rd molecules of oxygen gives 6.02 times 10 to the 23rd molecules of carbon dioxide. And rather than saying out that big number, we just say 1 mole of carbon plus 1 mole of oxygen gives 1 mole of carbon dioxide. But when we say the word 1 mole, we mean that's a big number of those individuals, whatever that individual may be. Okay, so now that we've reviewed for a second about what is the mole number and what it means physically, then I want you to practice here a little bit converting between numbers of individuals and numbers of moles of atoms. And so what I have on the next several slides are practice problems. First, you're going to practice converting between the number of individuals to the number of moles. How many silver atoms are in 3.2 moles of silver? Then I want you to practice converting between numbers of moles and the mass of a particular substance. And then numbers of moles and the mass of a substance, only using English units. And then after you've done all that, I want you to make sure that you remember how to calculate molar masses for compounds, and then do the POGL exercise on percent composition.